Welcome to ClickMyProject.com. Now we're going to discuss about the project High Security Physical Layer Encryption Scheme for SCMA FBMC in 4-mode fiber. Now we're going to discuss about the abstract of the process. The benefits of end-to-end learning has been demonstrated over the communication channels but has not been quantified over the realistic wireless communications channels models. This process aims to fill this gap by exploring the gains of end-to-end learning over the frequencies and then the selective fading channel using the OFDM. We identify other two sources of perform improvements. The first comes under the encoding and decoding without the losses of the bit error rate. Second, it comes under the entirely eliminating the orthogonal pilots by modulating combined with the conventional QAM or else the optimized constellations. Hence, in this process, the main objective to improve the SNR values and then reduce the BER rate. In case if the BER is reduced, means automatically the SNR value will be increased. That will be the vice versa process. Now we are going to discuss about the flow diagram of the process. This is the overall working flow we have presented in this project. The module consists of the process such as input data, pre-processing, encoding, transmitter, receiver, decoding, output data, then finally performance estimation. And first, the input data will be generated by generating the random nodes. So first of all, the random nodes will be generated at the any positions. After generating this kind of random data, we just move to the pre-processing. In this pre-processing, it will check whether the missing values are not, or else it will arrange the values and then plotted as an nodes. After doing the pre-processing, we just move to the encoding step. In this encoding step, the serial to parallel conversion will be done to encode the data. Then transmission will be started. So in this transmission stage, we have two stages of steps. One is the IFFT, then the modulation. So for modulation, we are using the QAM modulations. Then after doing the modulation, the data will be go to the receiver side. So in this receiver side, first of all, the encoded data will be received from the transmitter. Then it will go for the decoding process. So in this decoding process, we are again doing the inverse process of encoding by using the FFT method to inverse the data, then retrieve the original data. After getting the output as an original data, we just move to the performance estimation. So in this performance estimation, we have evaluated the performance like SNR and BER rate. Now we are going to discuss about the initial running procedure of the process. At first, we have to open the Octave software. In that Octave software, we are using the Octave version 7.1.0. It was mentioned here. So first of all, we have to open the software. After that, you just change the path as it is you have in the main file. So once you change the path, you have to select the main_GUI.yam and you have to just click the run. So once you executed the main file, the new user interface will be open. In that user interface, you can see the several push buttons in the right side for the controlling purpose, and then the several axes and table in the left side for the display purpose. Now first of all, we have to click the button input data. Once you click the button input data, the input data will be generated randomly like this. We have around 100 data as an input, so we have generated as an random numbers. Once you change this one, means automatically randomly it will generate the 100 data as an random manner. After generating the input, we just move to the pre-processing. So in this pre-processing, it will doing the plotting steps by using this two axes. In this axis 1 and the axis 2 displays what are the nodes present in the input data. After that, the encoding will be carried out. So in this encoding step, after you clicking the button encoding, the IFFT process will be carried out. So the encoded data will be shown in this table, and then the corresponding plotting will be shown in this axis 3. After doing the encoding, we just move to the decoding step. So this is relevant to the receiver side. So once you click the button decoding, the decoded data will be shown in this axis 4, and then the corresponding data will be shown in this table. So after that, we have to evaluate whether the data is working fine or not. So after retrieving the data, whether the data is correct means the total number of data will be the 100, the corrected data will be the 10, so the number of error data will be the 0. Like that, how much of data will be corrected, and then how much of error was occurred, it will be displayed here. Then finally, performance estimation. So in this performance estimation, we have to evaluate the performance like SNR and BER. So the BER will be reduced in this one, so the SNR will be reduced in this graph. So figure 1 represents the bit error rate, then the figure 2 represents the SNR. Thanks for watching this video.